So hello everyone. So I hope everything is well. Visit teaching graphing sine functions in case you want to review this portion. Before we proceed, let us just try to recall the general formula for the sine function, which is f of x equals a, that's the amplitude, sine of bx minus c plus d. Okay, so your a determines the height of your graph, your b determines the period of your graph, this c and b determines the phase shift of your graph, and then your d is for the vertical translation. So meaning to say, a and d are used to transform the y values of the graph, and then this b and c transforms the x coordinates in your graph. Okay, so let's just try to recall the parent function, which is y equals sine of x or sine x. Okay, so we know that the graph, okay, starts at 0 and ends at, this is 2 pi, okay, from 0 to 2 pi. And we know that this point right here is pi because that's the midpoint between 0 and 2 pi. This is gonna be, that's the midpoint between 0 and pi, and that's pi over 2, correct? And this one is the midpoint between pi and 2 pi, so that's 3 pi over 2. Okay, 3 pi over 2. And we know that this graph has its maximum point at y equals 1 and the minimum point at y equals negative 1. So let me just try to write all the points on this graph. The this one point for this, that's 0, 0. We also have here that is pi over 2, 1. We also have here that's pi 0, right? Pi 0. This point right here is, we know that that is 3 pi over 2. That's negative 1. And we have at k, that's 2 pi 0. So as I have mentioned earlier, these points right here will be transformed later, okay, because of the values of a, b, c, and d. Okay, so I'm gonna give you one example. For example, we have let's say we graph y equals what number? Let's say 3 sine x plus pi, let's say minus 1. Okay, so the first thing that you need to remember here is first the phase shift. Okay, so where will we start the graph and where we will end the graph? Okay, so first method is you should know first where to start the graph, in which x coordinate. Okay, so you have to get all of those numbers inside the parentheses, and that's x plus pi, and we equate that with 0. Why 0? Because in our parent function, look at the parent function, we started the graph at 0. So it only means that this should also be equal to 0, right? Okay, so we find the value of x. So x equals negative pi, which means that we will be starting the graph at negative pi. Okay, not at 0. So therefore, these x values here will be transformed. Okay, all the x values here. So from there, instead of 0, that 0 becomes negative pi. Okay. Okay, so now where do we end the graph? So same procedure, we still get that one. So that's x plus pi. And where do we equate that? We equate that with 2 pi because that's where we ended the parent function in our that's where we ended the parent function at 2 pi. Okay, so 2 pi, so x equals, so we subtract both sides by negative pi. So we have 2 pi minus pi is pi. So instead of 2 pi, that's the ending, right? It's gonna be here. That becomes, okay, at pi. Okay, that's one method. Second method, you can just use the phase shift, that is c over b, to know where to start. You know that your c is negative pi. That's not positive because the form is minus pi. That's negative pi over our b here is equal to 1. There's 1 here, right? Yeah. So we have 1, so that's negative pi. So same. Okay. Now how do we end that? So we can get the period first if you want, and the period is given by 2 pi over b. So 2 pi over b, our b is 1, right? So 1. So that's 2 pi. So if that's 2 pi, you just need to add negative pi, this negative pi right here, plus 2 pi, and you will get pi. So it's gonna be the same here. So you can choose either of the two. If you are confident in the first method, go for it. If you want the second method, it's the same thing. Okay. All right. So that's the first thing. So if you're able to identify now where to start and where to end the graph, let us start to find let's try to find the other x coordinates. Okay, we still have 3 remaining. So if you want, you can make now your Cartesian plane to see the coordinates, x coordinates. So this is your x coordinates, or that's your x-axis, it's your y-axis. Let's say this is at negative pi because that's where we start, and then we're going to end at pi. Okay, so we can say that this point right here is 0 because that's the midpoint between negative pi and pi. Then what about this? The midpoint between negative pi and 0 is negative pi over 2, and this point right here is pi over 2. That's the midpoint between 0 and pi. So we now have from negative pi, okay, then negative pi over 2, then 0, and then we have pi over 2. Next, so we're already done with this inside the parentheses. Okay, let's just try to fix that. So that's x plus pi. Okay, so next is, what about this 3 here and this negative 1 here? I mentioned earlier that that will transform your y coordinates. So all the y coordinates here, 0, 1, 0, negative 1, and 0, will be multiplied by 3, and then we subtract 1. Okay, so let's start here in the 0 here. So 0 times 3, this is times 3, so that's 0 minus 1, that's negative 1, right? And then we also have at 1. So since that's 0, same as here, that's still negative 1. And same as here, that's still negative 1. Okay? So what about this one right here on the second point? This one right here. So same procedure, we multiply that by 3 because this is 3. So that's 3 minus 1. That's 2. Okay. And one more point, this is negative 1. Okay. So multiply negative 1 by 3. This is 3, right? So that's negative 3 minus 1 is negative 4. So these now are our new points of the graph. So let's try to locate or plot all those points on our xy plane. So we have 1 and 2 because that's the highest point. And then we have at negative 1, negative 2, negative 3, and negative 4. Negative 1. Okay? So we connect all the points now. We have at negative pi negative 1 is going to be here. We also have at negative pi over 2, positive 2 there. And then we also have at 0, negative 1. This is 0, negative 1. We have pi over 2, negative 4 is going to be here. And then we go back at we're going to end at pi negative 1 is going to be here. So the graph would look like this. So let's just try to connect all the points smoothly as possible. So there. So those points right here are just these points right here, okay? So don't worry. Okay. Okay, so let us try to identify the domain of this. Since you can still extend this infinitely, because that's this the one I drew is only one cycle of the graph, so you can still graph that like this and so on and so forth. Okay, so that's the graph actually. So the domain here, okay, wait, let's make it more thinner or more thin. So we have the domain here will be all real numbers, okay? Set of all x such that x is an element of real numbers, since we can extend the graph in both directions. And then the range, what's our range? The graph is only from negative 2 to from positive 2 to negative 4, so that's the range. So from the set of all y such that y is an element of real number such that y is greater or equal to negative 4 but less than or equal to 2 there. Okay, so that's now the graph of our sine function.